Today we're going to take a look at binomial probability. So we are going to use the ideas of the past couple days of binomial expansion. So if an experiment is binomial, the following must exist. You can only have two outcomes. There's a fixed number of trials, everything must be independent, and the probabilities are consistent. So if we take a look at this first one, a basketball player makes a free throw 2/3 of the time. What is the probability that he will make 4 out of 5 free throws? So if these are our free throws, he's only going to miss one. So let's say he misses this one. Well, this probability would be 1/3, 2/3 he makes it, 2/3 he makes it, 2/3 he makes it, 2/3 he makes it. But does he have to miss that first one? He could miss the second one, so 2/3 would go here. 1/3, 2/3, 2/3, 2/3. Or he could miss this one, or he could miss this one, or he could miss this one. So all of these are the same. This probability would be 1/3 times 2/3 to the 4th. And again, all of them would be the exact same. And since he could do this or this or this or this or this, then we would add those all together. Now an easier way to do this is there's 1, 2, 3, 4, 5 different ones. So one way we could think of it is there's 5, the number of way to choose 4, we could say are successful shots. So then there's 2/3 to the 4th power times 1/3 to the 1st power. And so that 5 choose 4, so that's what we talked about the other day. So we can go to our calculator here. And let's see if you guys remember, whoops, it's menu probability combination 5, 4 times 2/3 to the power of 4 times, and it would be 1/3 to the power of 1. So we have 80 out of 243. So one way we can think of it, it's always going to follow this pattern. The probability equals our total, and we're going to choose our number of successes, and then it's the success probability to the number of successes times, we could call it our failure probability to the number of failures. So we are going to take a look at a couple more here and see what we can come up with. So this next chunk that we are going to look at, see if I can make this a little bit bigger here. There we go. That should be better. Whoops, we'll erase that. Sorry about that, guys. So this next one, if cared for properly, a tree has survival rate of 90%. If 10 trees are planted, what is the probability that 10 would survive? So 10, we want the 7 to survive. So then our probability for survival would be 0.9 to the 7th, and then our probability that it doesn't survive would be 0.1 to the 3rd. And then again, this is something we can just go and type into our calculator. So menu probability combination 10 choose 7 times 0.9 to the power of 7 times 0.1 to the power of 3. And we have 0.0574. So our next one here, 8 out of 10 people will recover from a certain virus. In a group of 7 people who are infected, what is the probability of 3 that will not recover?
Good morning, Orioles. The equity team is meeting in the media center
there's a
classroom
variety
at this time.
of ways that we
Happy
can look
Friday.
at this. If we do 7 choose 3, We want this that they will not recover. So our probability that they will not recover would be 0.2 to the third times, let's see, that you would recover would be 0.8 to the fourth. You would get the same thing if you chose, if you want 3 people to not recover, we want 4 to recover. So that would be 0.8 to the fourth times 0.2 to the third. And if you remember relating this to Pascal's triangle, that's because it is symmetric there. So, oh no, I think this stopped working. Hold on a second, guys. Let me see if I can get it working again. Let's see. Whoops, now everything disappeared. Oh no, let's see if we can get that to come back here. So, sorry about that, guys. So let's see if we can get this typed into our calculator. So we have menu probability combination 7, 3 times 0.8 to the power of, whoops, not 0.8, 0.2 to the power of 3 times 0.8 to the power of 4. So we have 0.11466, but you can see if we did it the other way as well, if we did 7, 4 times 0.8 to the power of 4 times 0.2 to the power of 3, we'll end up with that exact same thing. So 0.114115, we'll round it to. So the next one we're going to take a look at. Using number 3, what is the probability that at least 5 people will recover? So we could have 5 or 6 or 7 recover. So we could have 7 choose 5. So this is 5 recover. So 0.8 to the fifth times 0.2 to the squared. Plus if we had 6 recover, we'd have 7 choose 6 times 0.8 to the sixth times 0.2 to the first. Or we could have 7 choose 7 times 0.8 to the seventh times 0.2 to the 0. And we could type that into our calculator, but this is a lot to type in. So I'm going to show you something on your calculator that you can do instead. So if you scroll back up here, let's see on your, or actually you'll paste in this next thing right here, calculator hints. The calculator will actually do all the work for you. You just have to be okay with what you're typing in. So, here would be your calculator hints. You press menu number 5 probability number 5 distribution, and then you choose one of these. One of them is PDF, and one of them says binomial CDF. PDF is for if you're just trying to find a single value. Exactly. CDF is if you're trying to find a range, like 5 or 6 or 7. So you have your number of trials on there, the probability of success, and then single is just if you want so many successes, but then it has lower and upper bounds. So this one, since it's a range, what we can do is we can go to our CDF. So if you hit menu, probability, distributions, and you do have to scroll down for this one, so binomial CDF, so there was 7 trials. Our probability for success was 0.8, and we wanted everywhere from 5 to 7 people. And all we have to do is click OK, and there it is 0.85. let's see, 0.852. So our answer for this one would be 0.852. So what we're going to do next is I want you guys to pause it and look at these problems, and we're going to do these all by your calculator. So go through and you're going to see if they're a binomial PDF or a CDF. Once you've done that, start the video again to check your answers. Okay, so let's take a look and see what you got for these. So this first one, the probability that Tim will sink a foul shot is 70%. If Tim attempts 30 foul shots, what is the probability that he sinks exactly 21? So this was a PDF. If we were to do this without a calculator, it would be 30, he's choosing 21, times 0.7 to the 21, times 0.3 to the 9. So on our calculator, there are 30 trials. Our probability of success is 0.7, and we want that he sinks exactly 21. So let's have you guys type these into the calculator and see what you get for that one. This next one, approximately 97% of the eggs are not cracked. If you buy 2 dozen eggs, what is the probability that at least one is cracked? So this is at least, so it's a CDF. We have 2 dozen eggs, so there's 24, and we want at least one is cracked. So if we looked at that, what's our probability that they're cracked would be 0.03. At least one, our lower bound would be 1, and our upper bound, we could go up to 24. This next one, a hotel elevator has 4 elevators. One of them is a freight elevator. When pressing the button, one elevator randomly services your floor. If you use the elevator 7 times, what is the probability that you get the freight elevator exactly 4 times? So, if we were to write this by hand, 7, choose 4, because we want it 4 times. So there's 4 elevators, so it'd be 0.25 to the 4th, and then 0.75 to the 3rd. So our number of trials is 7. The odds that you get that freight elevator is 0.25, and you want it exactly 4 times. The next one, an archer has a 25% chance of hitting the bullseye on a target. What is the probability that the archer will hit at most 3 out of 5 times? So that is a range. So this could be, he could hit it 0, 1, 2, or 3 times. So the number of trials, how many times is he doing this? 5 times. The probability that he hits it is 0.25, and we want at most 5, so, or most 3, so from anywhere from 0 to 3. The next one, a basketball player has a 60% chance of making each free throw. What is the probability that he makes exactly 3 out of 6 free throws? So exactly 3 out of 6. Oh dear, sorry, let's see if we can get this back running again. There we go. So by hand, this would be 6, choose 3, 60% chance of success to the 3rd, 40% chance of failure to the 3rd as well. But on our calculator, there's 6 trials, 0.6 chance of success, and you want to make it exactly 3 times. And the last one, an agent sells life insurance policies to 5 equally aged healthy people. According to recent data, the probability of a person living for 30 years or more is 2/3. Calculate the probability that after 30 years, at most 3 people are still living. So that's a CDF because we want at most. So we could have 0, 1, 2, or 3 people still living. So he sells it to 5 people. The probability of a person still living is 2/3, and we would go from 0 up to 3.